Hello again, everyone. Welcome back to yet another devlog for my Voxel ray tracing engine. This month, I tried and failed to implement a totally new rendering method, added saving and loading the voxels to disk, and created a system for adding different shapes to the map. I've also decided to release the source code for this project publicly on GitHub, so check the description if you are interested in checking it out. As I just said, the first thing I tried to implement this month was a totally new rendering algorithm. The way that this was intended to work is that I would calculate the lighting for each pixel, and then sum up these pixels for each voxel and average them to maintain per voxel lighting, also reducing noise in the process. This was the first thing I got working, and it shows how many pixels each voxel takes up on the screen. The brighter a voxel, the more pixels it takes up. This was the first step in creating an average. It was then pretty quick to finish the rest of the rendering method. Here is the new method completely working. You can see how the lighting is calculated per each pixel and then averaged for each voxel. However, when I tried a more complicated scene, I quickly realized that this rendering method would not work. It is incredibly noisy and runs at around 20 FPS, so increasing the number of samples isn't even an option. It was an interesting experiment, but I decided just to revert back to the old rendering method. I got right back to work and decided next to implement saving to and loading from disk. Because of the way I store voxels, this was as simple as dumping the contents of memory into a file and then dumping them back in again. I will likely add some sort of compression scheme such as run length encoding later, as the voxel data structure allows for these to work very well. The next feature I added was a system for generating different shapes to place in the map. Now, instead of just single voxels, you can place spheres, boxes, rounded boxes, ellipses, cylinders, cones, and toruses. I've also made it trivial to add more shapes as I use something called a signed distance field to generate them. Check the description for more information on that. Finally, I made some optimizations to the engine's memory usage. I managed to reduce the memory of a single voxel in the GPU by 1/2 and the memory on the CPU by 1/8. This did come at a cost though. Voxels are no longer able to store their own albedo color and instead have to choose from a 256 color palette. However, I think that 256 user-defined colors should be more than enough for most uses. That's the last thing I have for you today. See you next time.